So picture this. It's 1985, right?
Okay.
And a world-famous scientist is murdered in her remote cabin up in these incredibly dense, mist-shrouded mountains of Rwanda.
Yeah, it's such a tragic, visceral scene.
It really is. And decades later, researchers are actually still tracking the very same critically endangered animals that she basically gave her life to protect. But today, they aren't just hiking through the mud. They're doing it using, like, invisible lasers fired from a billion-dollar NASA satellite orbiting the Earth.
Which is just a wild technological leap.
Right. I mean, the jump from a muddy, bloody crime scene in the jungle to, cold, distant algorithms processing spatial data in some sterile lab, it just seems impossibly vast.
We imagine biologists looking through microscopes, and then aerospace engineers are off building satellites, and novelists are, typing away in entirely separate universes.
Yeah.
But the reality of how we actually come to understand something is incredibly complex as an entire ecosystem. It's far more chaotic and, well, far more interconnected.
And that is exactly what we're here to explore. I mean, we are talking classic primate-based sci-fi novels,
Always a good time.
a super visceral historical memoir from the 1980s, an analysis of modern career paths, and cutting-edge remote sensing research papers. And we're going to reveal the hidden thread connecting all of these seemingly unrelated documents.
It's going to be a fun one.
It is, because that thread is a concept called consilience. We're exploring how consilient thinking, which is like the deliberate synthesis of knowledge across entirely different fields, is basically the ultimate secret weapon in modern scientific research.
Absolutely.
Specifically, we're going to see how fictional literature completely recontextualizes a modern spatial analysis study on Rwandan mountain gorillas.
To give you a visual sense of this journey, I want you to imagine the backdrop behind me shifting. We are starting in this dusty Victorian-style library, right? We're surrounded by philosophy and mid-century paperback fiction.
Okay, I see it.
But we're going to end up standing in the glow of a high-tech satellite control room. Because the materials we are drawing from chart this exact path. We begin with E.O. Wilson's foundational philosophy of science.
Right.
Then we move to primate-focused fiction. Specifically, Pierre Boulle's 1963 novel Planet of the Apes and Michael Crichton's 1980 thriller Congo.
Two absolute classics.
For sure. And from that realm of imagination, we hit the literal ground truth with Dian Fossey's boots-on-the-ground memoir, Gorillas in the Mist. And finally, we arrive at a recent geographic study by researcher Gabriel Stroop, using NASA satellite data to map mountain gorilla habitats in Rwanda. The overarching lesson hidden in this whole stack of reading is that to truly understand an animal, you can't just look at spreadsheets and laser measurement.
You have to look at everything else, too.
Exactly. You must look at culture, history, and biology all at once.
So we have to start at the very beginning of that journey with this word, consilience. It comes from E.O. Wilson's 1998 book of the same name. But before we get into what Wilson was, actually arguing for, we probably need to understand what he was arguing against. Why was he even writing this book in the late 90s?
Well, Wilson was reacting to a massive, centuries-long fracturing of human knowledge. Because if you go back to, say, the Enlightenment, there was this prevailing belief that all knowledge was intrinsically unified.
It was all just philosophy back then, right?
Basically, yeah. But over time, as our tools became more and more specialized, a deep chasm formed. On one side, you have the natural sciences, so physics, biology, chemistry.
Hard sciences.
Right. These disciplines operate on a strict quest for objective reality. You observe a phenomenon, you isolate the variables, you test a hypothesis.
And you gather empirical, measurable data to find out what is physically true.
Exactly. You want to know the exact weight of the rock, the speed of the chemical reaction, the genetic makeup of the cell. Hard facts.
Okay, so that's one side.
But on the other side of this growing chasm, you have the social sciences and the humanities. Sociology, anthropology, literature, cultural studies. And Wilson observed that as the 20th century progressed, the social sciences began to push back against that rigid empirical approach of the natural sciences.
Because humans are messy.
Yeah, exactly. There was a growing sentiment in some academic circles that human behavior, culture, and society were irreducibly complex. The argument was that you just can't reduce a human cultural movement down to, firing neurons or evolutionary biology.
That makes sense. I mean, it feels a little reductive to say poetry is just a chemical reaction in the brain.
Right, and that's exactly what the social scientists were saying. But furthermore, Wilson noted a dangerous trend where some social scientists might abandon the quest for objective truth altogether.
Oh, really?
Yeah, favoring social justification or tribal thinking. They began to view the biological search for underlying causes of behavior as prejudiced or reductionist or just completely missing the nuance of human experience.
So the biologists are saying, hey, everything is just cells and chemistry, and the sociologists are over there saying, you can't put a microscope on a cultural myth, you're missing the point.
And they completely stopped talking to each other.
Wow.
But Wilson completely rejected that separation. The core argument of his book, Consilience, is a plea to bridge that gap. He believed that everything, from the intricate mechanics of a biological cell to the sweeping cultural impact of a fictional story, is ultimately connected by underlying physical laws.
So he thought the divide was fake.
Exactly. His thesis is that we will never have a complete understanding of reality until we synthesize knowledge from all fields. The biologist needs to understand the cultural myth just as much as the sociologist needs to understand the cell.
Which brings us to the fiction in our reading list, which honestly at first glance feels like a really sharp left turn.
It does.
But if Wilson is right, and if we want to understand how scientists eventually studied the real biology of primates, we have to look at the stories our culture was telling about primates first. So let's look at Pierre Boulle's 1963 novel, Planet of the Apes.
Such a fascinating book.
It really is. A lot of people just know the movies, Charlton Heston on the beach. But the original novel is a very strict sociological commentary. Boulle creates an ape society that is entirely divided by class.
Right.
But the fascinating part is that he assigns those classes based on specific species stereotypes that humans held at the time.
Yet the structural hierarchy Boulle designed is incredibly deliberate. In his world, the chimpanzees are the intellectuals. They are the scientists, the thinkers, the ones driving the academic pursuits of the ape civilization.
Which kind of mirrors how we view chimps today,
Right.
right? As these clever problem solvers.
Exactly. But the gorillas, on the other hand, are depicted purely as brutes. They form the military, the police force, the hunters, basically the physical enforcers of the state.
It's just big, violent monsters.
Right. And the orangutans are positioned as the politicians and the religious leaders, the keepers of ancient dogma and bureaucracy.
And the driving theme of Boulle's book isn't just about apes acting like humans. It's really about the concept of imitation. He is exploring this terrifying idea that cultural advancement in these apes might not be true creative genesis.
Oh, interesting.
Yeah, it might just be rote, unthinking imitation of the destroyed human society that came before them, which is a deep sociological concept.
It really is.
And then we jump forward a couple of decades to Michael Crichton's 1980 novel, Congo. This is a completely different flavor of fiction.
Entirely.
It's this massive techno-thriller blend of primatology, computer science, and geopolitics. And sitting right at the center of it is the character of Amy. She's a mountain gorilla who was raised by humans and communicates using complex sign language.
And we have to pause right here and apply Wilson's theory of consilience, because the question is, why does a serious field biologist, someone reading satellite data in the 21st century, why do they need to care about the structural themes of Pierre Boulle or the techno-thrillers of Michael Crichton?
Yeah, why?
Because societal ideology directly dictates the trajectory of scientific progress. The cultural perceptions of primates that humans hold are heavily, heavily shaped by the stories we consume.
Okay, I see where this is going.
Those narratives inform the actual real-world hypotheses that scientists bring with them when they literally step into the jungle.
Okay, wait, I'm struggling with this a little bit. I mean, I understand that fiction reflects our culture, but does reading a sci-fi novel actually help hard science? Like, if I want to know how a real gorilla acts in the wild, why on earth am I reading Michael Crichton?
That's a fair question.
Isn't making a gorilla use a computer in a novel, or putting a gorilla in a military uniform in Planet of the Apes just projecting human traits onto an animal?
Anthropomorphizing them, yeah.
Exactly. Doesn't that anthropomorphizing actually ruin objective science? It feels like trying to read a map while wearing someone else's prescription glasses. You are inherently distorting the reality of the animal.
That is a very real risk, and actually early field biology was notoriously plagued by exactly that kind of projection. Early explorers went into the jungle expecting to find the bloodthirsty, chest-thumping monsters they read about in penny dreadfuls and early adventure serials.
Because that's what the culture told them a gorilla was.
Yes, they carried the bias of the fiction with them, which totally clouded their observations. But the other side of that coin is how fiction functions as a vital scientific sandbox.
The sandbox.
Yeah. Before you can rigorously test a groundbreaking hypothesis, you have to possess the capacity to imagine it in the first place. Fiction builds the foundational empathy and the imaginative leads required to ask questions that a purely empirical mind might never even consider.
Oh, wow. Okay, so it's not about the fiction being factually accurate. It's about the fiction expanding the boundaries of the questions we're actually willing to ask.
Exactly. Take Planet of the Apes. It forces a reader to confront the fragile boundaries of human versus animal cognition. It asks a deeply uncomfortable question. What happens to human dignity and our definition of consciousness when we are no longer the apex intellectual species?
Right. It blurs the line.
It does. It primes the cultural mind to accept that animals might actually possess rich internal lives. And Congo, by exploring the feasible limits of cross-species communication and highlighting the intense emotional bonds between humans and apes, it pushes the boundary of what the public thinks is biologically possible.
That makes a lot of sense.
Without the cultural imagination that can conceive of a communicating gorilla like Amy, it is highly unlikely that society would have ever funded or supported the very real, very expensive sign language studies in great apes that actually took place in the latter half of the 20th century.
Studies like Coco the gorilla.
Exactly. This is E.O. Wilson's Consilience in Action. It's the literature of the humanities providing the imaginative and ideological framework that the natural sciences then go out into the field to empirically test.
Okay, that makes sense. The fiction gives us the what if, and it generates the empathy needed for society to care about finding the answer. But, I mean, a sandbox is still just a sandbox.
True.
While fiction imagines what apes might do in some specialized fictional scenario, eventually scientists had to actually go out and see what they do in the real wild, which requires us to leave the conceptual world of the library and head into the very real, very punishing montane forests of Rwanda.
Yeah, we are transitioning from the theoretical to the visceral ground truth now. Which brings us to Dian Fossey's 1983 memoir, Gorillas in the Mist.
Fossey's story is a foundational text for a reason. She was one of Leakey's angels, which was the nickname for 3 pioneering female primacologists who were sent into the field by the famous paleoanthropologist Louis Leakey.
And his reasoning for choosing them was fascinating.
Yeah. He specifically chose women without extensive formal scientific training because he believed they would be free from the entrenched, rigid biases of academia at the time.
He wanted a blank slate.
Exactly. So he sent Jane Goodall to study chimps, he sent Buru Goldikas to study orangutans, and he sent Dian Fossey to the remote, high-altitude montane forests of Volcanoes National Park in Rwanda to study the mountain gorilla.
And her methodology upon arriving in Rwanda was completely revolutionary. I mean, the standard scientific practice of the era was to maintain extreme distance and objectivity. You stand behind a blind with binoculars, you take notes on a clipboard, and you never, ever interact.
Just totally detached.
Right. But Fossey abandoned that entirely. She didn't just observe the gorillas, she immersed herself in their society.
She literally lived among them. The memoir goes into incredible detail about how she learned to imitate their specific vocalizations, like grunting and belching to signal contentment.
Which is wild to think about.
It is. She mimicked their feeding behaviors, too. She'd sit there chewing on celery stalks right next to them. She learned their submissive postures, keeping her head lower than the silverback to show she wasn't a threat.
She became part of the troop, in a way.
Basically, yeah. She didn't look at them as this monolithic species. She recognized them as individuals. She knew them by their faces, gave them names, and meticulously documented their unique personalities and family dynamics.
But this level of intimacy extracted an unimaginably high cost. Gorillas in the Mist is not just a book about biology, it is a brutal survival narrative. She was living in a damp, freezing cabin at 10,000 feet.
I get cold just reading about it.
Right. And she details the constant struggle of navigating local political corruption just to maintain her research permits. Plus, she was fighting a literal violent war against poachers who were decimating the already fragile gorilla population.
Yeah, she was out there setting traps for poachers and organizing patrols to dismantle their snares.
She sacrificed her health, her personal relationships, and any semblance of a normal life. And ultimately, this intense, unyielding dedication ended in her murder in that very cabin in 1985.
It's just a harrowing read. But when we look at her legacy through E.O. Wilson's framework, Fossey was the ultimate early consilient scientist out of pure necessity.
Oh, absolutely.
She couldn't afford to just be a passive observer tallying biological data. If she wanted those gorillas to live long enough for her to study them, she had to smash every single academic silo.
She had to be a survivalist and a medic. She had to act as a diplomat, navigating the complex landscape of Rwandan conservation law and local governance. She had to be a rogue wildlife manager, a public relations expert trying to rally international support, and a behavioral scientist all at the exact same time. And her boots-on-the-ground work established the foundational baseline for everything we now know about gorilla ecology. Before Fossey, the cultural perception was largely dictated by the brute stereotypes seen in things like Planet of the Apes.
The monsters.
Yeah. Fossey proved empirically that they are not bloodthirsty monsters. She proved they are highly complex, deeply social, remarkably peaceful herbivores.
And crucially, she proved they are keystone environmental engineers, which actually is a perfect moment to pull in the paper from our source stack on savanna ecosystems, because understanding how an animal shapes its environment is critical to understanding where they choose to live.
That Savanna Ecosystems paper explores a really fascinating dynamic, how faunal activity, so the physical behavior of animals, actively drives local climates and shapes the landscape.
Oh.
It details how savanna chimpanzees in Senegal haven't just adapted to their harsh environment. They actively navigate and even predict the path of wildfires to access newly cleared foraging grounds.
Which is just terrifyingly smart. And the paper also touches on the savanna hypothesis, which is this major evolutionary theory looking at our own human ancestors.
Right, hominins.
It explores how early hominins had to fundamentally adapt their biology and behavior when the dense forests of Africa began to shrink and were replaced by wide-open terrestrial grasslands. Stepping out of the trees changed how they walked, how they used tools, and how their brains developed.
What that paper demonstrates is the underlying mechanism of primate survival. Primate behavior is inextricably linked to managing, reacting to, and altering the physical environment.
Right.
A chimpanzee in a savanna isn't just a passive resident. It is actively exploiting fire patterns. And when we look back at the mountain gorillas in Rwanda, they are doing the exact same thing, just in a vastly different biome.
A completely different world.
Yeah. A dense, steep, high-altitude rainforest requires a different set of adaptations. Because gorillas are massive, entirely terrestrial primates, they don't just live in the forest, they actively reshape it. They are constantly tearing down massive amounts of vegetation to eat, snapping bamboo and stripping bark, and they build complex, fresh ground nests every single night.
Just constantly remodeling the forest.
Exactly. They are physically modifying the architecture of the forest around them.
So, Fossey's method of living right there with them, watching them build those nests and chew that celery, was incredibly intimate. But if her deeply personal, face-to-face approach was so incredibly successful at changing the world's view of gorillas, if she single-handedly gave us this foundational biological understanding, why does the modern scientific study in our stack seem so obsessed with removing the human element entirely?
Well, that's the big question.
Right. I mean, we are jumping from a woman sitting in the mud holding a gorilla's hand to a scientist sitting at a computer looking at satellite data. If we know that human empathy and direct observation works, why rely on cold technology? You wouldn't claim to know a neighborhood just by looking at a Google Earth map. You'd walk the streets and talk to the people who live there.
That is the exact friction at the heart of modern conservation. The intimacy of walking the streets provides unparalleled qualitative data. You learn the personalities, the daily dramas, the nuanced social bonds.
Yeah, the stuff you can't measure with a laser.
But the harsh reality of Volcanoes National Park is that walking the streets is geographically punishing, immensely time-consuming, and as Fossey's murder tragically proved, incredibly dangerous. Fossey could intricately know a few dozen gorillas.
Okay, I see.
But what happens when you need to monitor the health and habitat of an entire regional population spread across sheer volcanic slopes? What happens when you need to understand how human encroachment and rapid climate change are affecting the entire 160 square kilometer ecosystem simultaneously?
You can't clone 1,000 Dian Fosseys and put them in the jungle.
Exactly. It's a problem of scale. The intimacy doesn't scale. To ensure the survival of the species on a macro level, modern science had to look to the sky. We needed a vantage point that a single human on the ground, hampered by mud and thickets, simply cannot achieve.
You have to map the whole neighborhood at once.
We needed to map the entire neighborhood at once, not just one house, which leads us directly to the modern spatial analysis of that exact same park.
Okay, let's get into this. This is Gabriel Stroop's research paper assessing habitat selection in mountain gorillas through remote sensing, and it is set in the exact same 160 square kilometer stretch of Volcanoes National Park in Rwanda, where Fossey lived and died.
Which is a great full circle moment.
And just for some context, this park is currently slated for a massive 20% expansion project to give the growing gorilla population more room. which makes mapping their preferred habitat incredibly urgent. But instead of hiking through the mud with a clipboard, this study relies on technology operating hundreds of miles above the Earth.
The study utilizes two distinct types of satellite data to try and understand the forest from above. The first is optical imagery from the Sentinel-2 satellite. Think of this as a highly advanced traditional camera taking pictures of the Earth's surface.
Okay, pretty straightforward.
Yeah, this is a form of passive remote sensing. It just captures the sunlight reflecting off the Earth. And from this imagery, the researchers calculate a metric called NDVI, which stands for Normalized Difference Vegetation Index.
Okay, so if I'm understanding this correctly, NDVI is basically just measuring how green the plant life is, right? It's looking at the chlorophyll.
That is a great way to summarize it. NDVI measures the health, density, and vigor of the vegetation based on how the leaves absorb and reflect different wavelengths of light.
Right.
But optical imagery has severe limitations in a dense jungle. It only sees the roof.
Just the top layer of leaves.
Exactly. And that is why the second technology used in the study is so critical. The researchers used NASA's GD LIDAR. Now, LIDAR is an active remote sensing technology. It doesn't just passively capture sunlight, it actively shoots billions of laser pulses down to the Earth and measures the exact time it takes for those light pulses to bounce off an object and return to the sensor.
Because we know the speed of light, measuring that return time tells the satellite exactly how far away the object is.
Precisely.
So it's not just taking a flat 2D picture, it's mapping the 3D physical structure of the Earth.
Yes. And because a forest canopy isn't a solid wall, some of those laser pulses hit the top leaves, some slip through the gaps and hit lower branches, and some make it all the way to the forest floor.
Like dropping pebbles through a grate.
Good analogy. By measuring all those different return times, the LIDAR can construct a 3D model of the forest. It measures the height of the canopy, the density of the middle branches, and the structural complexity of the undergrowth. And from this 3D data, the study derives a metric called AGBD, or above-ground biomass density. This isn't measuring how green the leaves are. It is calculating the sheer physical volume, weight, and structural complexity of the wood and plant matter beneath the canopy.
Okay, so the study has these two massive data sets, the greenness from the camera and the 3D structure from the lasers. How did they actually use this to figure out what the gorillas want? I mean, the satellite can't see the actual gorillas through the trees, right?
Correct. The satellites map the environment, not the animals. To connect the two, the researchers took known GPS coordinates of where gorillas had been physically sighted on the ground.
Okay.
They pulled these coordinates from a large public biodiversity database called iNaturalist. They then overlaid those specific gorilla sighting locations onto their satellite maps. Yeah, they looked at the environmental data, so the NDVI and the AGBD at the known gorilla sites, and compared it against random background points scattered throughout the rest of the park. The fundamental question was, do the areas where gorillas hang out look statistically different from the rest of the forest?
And the results of this comparison are just fascinating because they highlight the exact limitations you were just talking about. Let's look at the NDVI, the optical greenness first. When they compared the greenness of the gorilla locations to the random locations, the results were virtually identical. The camera couldn't tell the difference at all.
Which tells us everything about the limits of optical satellites in a tropical biome. I mean, why was the NDVI identical? Because a montane rainforest is incredibly dense, lush, and aggressively green almost everywhere.
It's all just green.
To a camera in space looking down, Volcanoes National Park essentially reads as a solid, uniform roof of maximum greenness. The optical data saturates. It cannot differentiate between a patch of forest that gorillas absolutely love and a patch they completely avoid, because the top layer of leaves looks exactly the same everywhere.
But the laser data completely changes the game. When they looked at the AGBD, the structural biomass density measured by the LIDAR, there was a clear difference.
A very clear difference.
The biomass density was higher at the known gorilla sites. But more importantly, the variance was much lower. The gorillas were consistently choosing areas with very specific high-density structures, while the random points had a huge range of high and low biomass.
And this is where we have to ask why. We have the data, but what is the mechanism driving the behavior? Why do gorillas consistently prefer higher biomass?
Right, back to the biology.
It goes back to our discussion of how they interact with their environment. Mountain gorillas can weigh up to 400 pounds. They are massive terrestrial nest-building machines.
Absolute units.
Yeah. And a 400-pound animal does not want to navigate through fragile, regenerating forest patches or old, abandoned farmland with thin, spindly undergrowth. They require stable, mature forest patches that have deep, complex, robust subcanopy structures. They need thick, sturdy material for their immense daily foraging needs, and they need strong structural foundations to build their ground nests every single night.
So, using the metaphor from earlier, the NDVI is just looking at the neighborhood's paint job. And it turns out, in the rainforest, every single house is painted the exact same shade of green, so the camera learns nothing.
I love that, yes.
But the AGBD LiDAR is like an X-ray looking at the structural foundation of the houses. It can tell which houses have deep basements, solid oak framing, and thick walls. And the gorillas are choosing the most solidly built houses on the block.
That is exactly what the data shows.
But wait, I had a logistical question about this. If gorillas are these massive environmental engineers, constantly tearing down bamboo and crushing vegetation to build nests, wouldn't a laser from space see a trail of destruction?
You'd think so.
Shouldn't we see patches of suddenly lower biomass where a troop of 30 gorillas just camped out and ate everything in sight?
You would logically think so.
Yeah.
But the reality of the technology and the environment completely changes that expectation. It basically comes down to two factors: spatial resolution and ecological recovery.
Okay.
The GDI LiDAR doesn't measure the Earth inch by inch. The laser pulses have a footprint, a circle in the ground that they measure, and that footprint is about 25 meters across.
That's huge.
It's roughly the size of a large house. So it is a fairly coarse macro measurement. While a troop of gorillas certainly alters the vegetation around them, a 25-meter aggregated measurement is not going to easily isolate the fine-scale, messy trail of a daily foraging path beneath a multi-layered canopy.
So the footprint is just too large. It's like trying to find a single missing brick by measuring the total weight of the entire building.
Exactly. And furthermore, a tropical montane forest is an incredibly dynamic, fast-growing ecosystem. The vegetation recovers and regrows remarkably fast.
Oh, right, the jungle reclaims it.
So between the coarse resolution of the satellite footprint and the rapid regrowth of the plants, the technology simply cannot track the fine-scale, day-to-day behavioral impact of the animals. We can see the broad structural habitats they prefer to live in, but we cannot see their daily footprints from space.
So let me summarize where we are at. We have these billion-dollar NASA tools, but they can't see through the canopy with cameras, their lasers are too coarse to track daily behavior, and all the data ultimately tells us is that gorillas like thick, sturdy forests. Which, quite frankly, Dian Fossey could have told us with a notebook 40 years ago.
Well,
It sounds like the high-tech satellite data isn't actually giving us the full story at all.
and that realization is the most critical revelation of the entire spatial analysis study. The paper itself is incredibly transparent about this.
Oh, really?
Yeah. The data doesn't just reveal the physical limits of our technology. It reveals a massive fundamental human bias embedded in the data itself. And to solve this bias, we are forced to abandon the sterile realm of pure data and combine the satellite findings with the social sciences.
Oh.
Which brings us full circle, directly back to E.O. Wilson's concept of consilience.
Wow, okay. Let's unpack that observer bias because the spatial analysis paper explicitly lists its critical limitations. First, there's the weather. Persistent cloud cover in Rwanda frequently ruins the optical satellite imager, making it incredibly difficult to get a clear year-round picture of the park.
It's just a constant problem.
But the much more insidious issue is where the GPS data for the gorillas came from in the first place.
Let's trace the origin of those data points. As we said, the coordinates were pulled from iNaturalist, which is a platform driven largely by citizen science, park rangers, and ecotourism.
Right.
So the GPS points used in the study do not represent a random, mathematically even sampling of all the wild gorillas living across the entire Volcanoes National Park. They almost exclusively represent sightings of habituated troops.
And just to clarify for anyone unfamiliar, habituated troops are specific gorilla families that have been subjected to a years-long process of slow acclimation to human presence.
Yes.
They are the ones designated for the ecotourism industry, so tourists can pay to hike in and take photos without the gorillas fleeing or attacking.
Precisely. The Rwandan government, for the safety of both the animals and the people, maintains a very strict separation. There are wild, uncontacted troops that roam the deep park, and there are habituated troops whose movements are closely monitored for tourism.
Okay, I see the problem.
Therefore, the data points we are feeding into our high-tech objective spatial models are inherently skewed. They represent where tourists and guides go, not necessarily the full range of where all gorillas naturally want to go.
Oh, wow. The implications of that are huge. We literally cannot understand the spatial distribution of these animals without understanding human economics and the global tourism industry.
Exactly.
The habituated gorillas might be choosing their daily habitats based on where the human trail access is easiest, or they might be lingering in areas where they were historically habituated decades ago. They might be making choices based on their relationship with humans, rather than just choosing based on the natural biomass of the forest.
This is E.O. Wilson's exact warning playing out in real modern science. If a researcher looks at the LiDAR data in a vacuum, completely ignoring the social sciences, human economics, tourism behavior, and park administration history, they will fundamentally misinterpret the hard biological data.
They'll think the biology is driving it when it's actually human economics.
Exactly. You cannot point to a coordinate on a map with high biomass and say, gorillas prefer this exact spot because of the physical structure, without also asking the sociological question, is this coordinate just a 20-minute walk from the eco-tourist lodge? The human element biases the biological element.
This realization connects so perfectly to the job exploration paper we have in our source stack. That paper analyzed different career paths in animal science, looking at the skill sets required for various roles.
It's a really eye-opening paper.
And it highlighted that conservation scientists and zoologists require arguably the most incredibly diverse knowledge bases out of almost any animal-related career.
The contrast is just striking.
Oh.
I mean, a basic animal caretaker needs practical, hands-on skills. A lab scientist needs deep, hyper-specialized biological and chemical knowledge. But the modern conservationist cannot survive in a silo.
The paper showed that a modern conservation scientist obviously has to understand the core biology of the animal, but to actually do their job, they also need high-level knowledge of geography and GIS mapping to track habitats.
Right, the tech side.
They need to deeply understand local administration and law to navigate park boundaries and government regulations. And they need public relations, customer service, and communication skills to manage the massive ecotourism industry and negotiate with local communities whose farmland borders the park.
The modern conservationist is the literal embodiment of consilience. Dian Fossey entered the field with sheer will, forced to become a survivalist and a rogue diplomat out of sheer desperation.
Because she had to.
Yeah, but today, that multidisciplinary approach is a formalized requirement. To save a species today, a professional must be a data scientist analyzing LiDAR, a biologist understanding primate behavior, and a sociologist understanding human economics.
All in one person.
They need the deep, empathetic biological intuition of Fossey, the rigorous spatial mapping skills of a modern researcher like Stroop, and the sociological awareness to manage the endless, messy interface between humans and wildlife. Because the human element is never going away.
So bringing this all together, what does this actually mean for you, the listener? I mean, does this revelation mean the satellite data is basically useless because it's just tracking tourist routes? Should we just throw out the LiDAR models and go back to hiking in the mud with a notebook?
No, it absolutely does not mean the data is useless. It means the satellite data is just one piece of a much larger, highly complex puzzle.
Right.
To protect the mountain gorillas, or, frankly, to solve any deeply complex systemic problem in your own career or life, you cannot just study the leaves and the lasers. You have to study the local economy. You have to study human psychology. You have to understand the cultural history and the fictions that brought the tourists to that mountain in the first place. You have to synthesize the cold data with the messy human context.
This has been such an incredible journey through this stack of sources. It's really amazing how they all weave together. We started with fictional literature, Planet of the Apes and Congo, which revealed how our cultural biases shape our expectations, but also provided the imagination and the empathy to even care about studying the internal lives of apes.
The spark of imagination.
Yeah, and that cultural foundation paved the way for Dian Fossey, who gave us the intimate, boots-on-the-ground biological reality, sacrificing everything to prove they were complex engineers, not movie monsters. Then, realizing that intimacy doesn't scale, the satellites gave us the macro-environmental perspective, allowing us to see the structural foundation of their home from space. And finally, consilient thinking is what allows us to merge all of these perspectives together, to recognize the human bias in the satellite data, and to actually create a functional plan to save the species.
The entire journey proves Wilson's thesis. True understanding, the kind that can actually change the world, doesn't live safely inside a single academic discipline. It lives in the friction and the intersections between them.
So as we wrap up today's deep dive, I want to talk directly to you, the listener. Whether you are prepping for a major strategic meeting, leading a diverse team, or just trying to be a more informed citizen of an increasingly complex world, the lesson of the mountain gorilla is that siloing your knowledge is incredibly dangerous.
It really is.
Reading widely pulling, from Victorian literature to modern geographic data to sociology to history, gives you a massive superpower. It allows you to see the blind spots, the biases, and the contextual gaps that the hyper-specialists completely miss.
And I want to leave you with a final, lingering thought to mull over as you go about your day. We have traced how our understanding of these magnificent creatures has evolved. It started with the fearful anthropomorphic myths of early science fiction.
Right.
It evolved into the intimate, deeply emotional, and ultimately tragic physical contact of Dian Fossey. And now it has shifted to the cold, distant lasers of NASA satellites orbiting the Earth.
The lasers in space.
Yeah. But as we move forward into the future, relying more and more on artificial intelligence, remote algorithms, and distant sensors to monitor the health of our planet, what happens when we remove the human observer entirely?
Oh, wow.
Can a machine or a perfectly objective model ever truly understand the delicate balance of an ecosystem without the messy, biased, empathetic, conciliant human touch that first taught us to love it?